Okay, let's get started. All right, so we're almost reached the end of the semester. So in this semester, we covered very broad topics of software engineering, including those design, as requirements, right? And what is the software engineering? Why do we need the software engineering? Also, we cover this kind of a testing, this kind of things, right? So here we also talk about those different tools in each stage of the software development. Like when we're doing the design, we have this UML, which is a set of notations to help us to modeling the system. Right? Yeah. So that's all. That's a lot of things. And last week we talked something about this testing, requirements, testing. So why do we talk about requirements and testing together? Because they are basically what we generate the test cases based on the requirements we get from the client, right? Because what we are testing for, what we're really testing for is this product do what it is supposed to do correctly? It is supposed to do what the customer wants, right? So test cases usually is generated from the requirements, right? And the when you specify the requirements, that's why when we specify the requirements, I remember one of the documentation we used this semester. For every of the requirement, we should have a trackable index for them, so that we know when this requirement excuse me, is identified, where it is designed, and where it is tested. It's all trackable. And also the testing I'm talking about is about black box testing. But white box testing is something you just care about this code. So you touch each line of the code, is the code working well? But you never touch this requirements with only white box. So usually we combine this white box and black box. Black box is you test more, and its test cases generated from the requirements. Yes. Okay, so after the testing, or after we learn all this, what do you think is missing from the cycle of the software engineering? Remember, we talked about software development model in the beginning, I think, in the very beginning. Waterfall model, remember? Agile, waterfall, those things. Right? Okay. So what I'm missing from what have we covered? So the next important thing, what is that? Maintenance? Yeah. Maintenance. Yeah, maintenance is a very important part. But what should we maintain?
The product.
Yes, the product. And what else can we maintain? What's that? The product, quality of the product, yes, but still the product. And there's something else we can maintain.
Are we maintaining the business?
Yeah, kind of. We're maintaining this business, this whole process. Actually, when we develop this software, the product is not only thing. It's not the only. Well, the actual software product is not only thing. We also, through the development in your team, you get a way of maybe, anyway, it's called collaboration, or you get a way of management of the team, this development process. So how do you organize this whole development activity? This whole process is something we can maintain, right? Because we establish some of the process. Well, I give you one of the project at the first time, you're trying to figure out how should we finish everything within the team. And next time I give you some similar project, will it be easier or not? It will be easier, right? Because the team has worked together. You have some sort of process. You know how should we supposed to get this done, right? So maybe at the first time I give you an assignment, your team is struggling trying to figure out where is my team member even. But second time, okay, you know that the process improved a lot, something improved, right? Okay, then the product is should be maintained, and also the management to your team, the process can also be maintained. So why do we maintain these two things? Product and the process. While we do testing of the product, we maintain the quality of the product, and we improve the process of our team or your company. So why are we doing all this? What's the purpose?
To make sure we're progressing according to the schedule, and then
Yes,
make sure
according to
the product is being updated and keeps being successful.
yeah, being successful, we want to stick to the schedule. We have some budget we want to stick to. We have a cost we have to stick to, and also we want to ensure that within this budget, within that deadline or this resources, we want to deliver this high quality product to our customers, right? We can take maybe since we have deadline, we have some resource, budget, funding. If we cut any of them, like cut the budget into half, it will eventually if I told you, okay, you have this certain amount of funding and deadline, okay, but suddenly I told you the amount of funding is cut into half, but we still need to stick to the original deadline. What do you think would happen?
If the funding is cut in half and we stick to the original deadline,
Yeah.
the product wouldn't have as many features, or
Yes.
would be more
The product will be screwed up. So the product will have a low quality, right? Okay, so what we want to talk about today is about something called quality assurance, Q&A. Well, sometimes I know some companies they're hiring Q&A, but merely doing this testing job. Okay, they call it Q&A work, but actually Q&A has more content than testing. Testing is a part of it for sure. Yeah. So Q&A includes the evaluation of the product and the process and the resources. So it's more about a management issue of the software development team in the software engineering. Okay. So let's see what is included. So what is a Q&A? Q&A is concerned with ensuring that software products are of a high quality. Of course, we want high quality, involving the both of the product and the process assessment. Okay. It's really kind of related to verification and validation. We have another course called verification and validation. It's kind of related to that. But V&V are technical software development process concerned with fault detection, but Q&A is more about a management function concern. All right. Q&A is a whole life cycle activity, not some certain stage of software development. It's a whole cycle. Remember, we talked about the process of software development. So Q&A, the process is about the whole cycle, and Q&A is the same thing. And Q&A consists of those procedures, techniques, and tools applied by professionals to ensure that a product meets or exceeds pre-specified standard during the product development cycle. Sure. Yeah. And the important thing to do that is we need a standard, right? If we want to measure something, if it's good or not, if the product meets the expectation or not, what we need is metrics, the standard. How can we do that, right? So we quality assurance entails ensuring that the product exceeds the minimum industry acceptable level of excellence. And think about quality assurance. And think about maybe the problem or the hard part of the quality assurance. What do you think? First is maybe the standard, right? We want to have some standard. How can we measure the quality, right? Okay, and what else could be a problem or hard difficulty of conducting quality assurance? Maybe prevent you from doing quality assurance. First is the metrics, the standard. And also it could be the resources, the cost, right? You need a Q&A, you need a person to do that, right? Yeah. And you need to allocate resources to do that. Yeah. Sometimes it's maybe increase the overhead of the team, maybe a lot of extra work. However, long-term speaking, it's a good thing to conduct a Q&A. You will see why it's a good thing later. Okay, quality of the process. So the quality, like I mentioned, quality of the process is an important part of Q&A. So it involves three parts. First is defining the process standards, monitoring the development process to ensure we follow this standard. We have a standard, we need to reinforce this standard, and also we reporting the software process to project management. Defining, monitoring, and reporting. More about management issue, remember. So there are a lot of standards which has been defined by a lot of organizations. Well, it's actually very hard to define this standards because the application domain of software is quite wide variety there. Right? We can build a software app, we can build a cell phone app, or we can build a system for the airplane. Are they the same? Are they the same? Can they using the same standard? No, because well, maybe some part, yes, they have some of the standard process in common, but those two application domain are totally different, right? So to defining some standard for the process is hard, but people are trying to do these things. So see, there are a lot of organizations that are doing this, like IEEE, DoD. A lot of them are doing this development of the standard. Yeah. Sometimes the teams, they develop their own standards to make sure that their development activity follows as the standards. Yeah. But the team standards, usually you should follow the principles from this big organization. Usually that's how it works there. Yeah. And problem is, first, standard is hard to design. And once we have the standard, actually it's very hard to follow the standard. Right? Like this program formats, design documentation. So sometimes all these things have been defined. You should do this, you should do that. Sometimes it's people do not follow because it's not checked at all. So I just finished my job, that's it. It's not checked. Well, because checking that standard sometimes it's costs something more. So it's very hard to find a balance there. But what we should remember is about the quality. We have the standard. Why we have a standard is not for us to increase the trouble, it's for us to increase the quality of the product. Right? So that's why we have the standard. Yeah. And this quality review is a significant part of the Q&A. And a review is a QA mechanism in which a group of people examine part or all of a software system or documentation with this purpose of finding the problem of the system. Like I said, this kind of review process costs a lot, so sometimes you're not sure if you want to do that, but for the long-term benefits, it's better to do this quality assurance and the review. And also this review are result, of course, they are recorded and documented. So types of the review, we just go through this quickly. We have something more important later. So it's design and program inspections. So we check the program. Management review, we check the process. And quality review, we have a team, a panel to review the whole area of this quality, include the product itself and this software process. And also we check if we have the standard. Have we doing the adherence to the standards? And also software metrics. So why do we need metrics? We use metrics to measure something. If we want to ensure the quality, metrics is an important thing. Yeah. The distinction between a craft and engineering principle is that craftsmen use qualitative methods, and in engineering, all those measurements is based on the quantitative techniques. You know the difference between those two? Quantitative and qualitative. Right. Can somebody explain the difference between these two?
So quantitative has to do with numbers.
Yes, numbers, data.
And then qualitative has to do with how good the quality is, right?
Yeah, quantitative. This analysis techniques we use means this objective. It's more objective. Okay, this objective data. Numbers to measure something.
Data can be counted.
Yeah, it can be count. You can compare. Alright, so more objective. But qualitative, more subjective. Right?
That can be measured.
Yeah. Well, it can be measured. Something you can say yes, good, bad. But what is good, what is bad is not very clear. It's more subjective, right? But quantitative is different. You have a very specific define of what is called good, what is A, what is B, what is C in the class, right? 90%, 80%, 60%, something like that, right? So metric, we use if we want to do quantitative techniques, metric is important. So it's a measurement which relates to a software system process or related documentation, right? So there are two classes. First is control matrix. The second is predictor matrix. What is the difference? Okay, it's important to remember the difference of these two. Control matrix is used by the management to control the software process, like the effort expended, elapsed of time, or used to refine the project planning process. So it's measure what we currently have, and the predictor matrix is measurement of the product attributes, which can be used to predict and associate product quality. Okay, like a ease of maintenance, which is prediction. Because the maintenance, we are not doing that yet. It's something in the future, but we want to measure that because we need to plan that. Right, so it's called predictor matrix and control matrix. Yeah, so we cannot measure directly what we really want to measure. That is the quality. We're talking about quality. But what we are doing is assume that a relationship exists between what we can measure and what we want to know. We should assume what we measure, they have something related to the quality. So what are we measuring? So what are we measuring is this, we cannot directly measure quality, but we're measuring different perspective of the quality, right? So we examine a product to determine if it has a desired attributes, those attributes. So we can give some attributes to one of the product. So those attributes is associated with different types of qualities. For example, here, see, we are measuring this quality with this Boehm's quality model. So we have different layers. At the very top is the general utility of the software system, and then so here it's a maintainability, S is utility, and portability. Okay, so here well, let's say portability, and S is utility and maintainability. Those three quality, second level quality attributes. Okay, look at this three: portability, as is used utility, and maintainability. Okay, so which of those attributes belongs to predict attribute? Predict metric. Yes, exactly. Yeah, that's what I just mentioned. So maintainability is something, it's kind of if it's maintainable, cost. And SSU's portability is something you can use to control this quality of the software. Okay, and with this model, how do we measure portability? We have a even more detailed layer here. It's device independence, and the self-contentedness. Okay. Also, within this SSU utility, we have the attributes of reliability, efficiency, and human engineering, which they all have a more attributes to trying to describe this top layer attributes. And for this attributes, that's something we can measure. We can measure about the quality of this product. Okay. Like if it's the device is independent, accuracy, completeness, consistency, we all have metrics to measure them. So that with this model, we can measure this general utility from layer up. You measure those things. And for this model, it reflects an understanding of the quality where the software does what the user wants it to do. Does it do that? Use the computer resources correctly, efficiently. If the software is easy for the user to learn and use, if software is well designed, well coded, and easily tested, maintained, right? And also there are the quality models defined by ISO. You know what is ISO? Yes, exactly. International Standard Organization. So it just published those different kind of standards to do things. And software standard, a lot of software standards published as well. Yeah. Well, the ISO 9126 quality model is a hierarchy model with 6 major attributes contributing to quality. Okay, so each right-hand characteristic is related only to exactly one left-hand attributes. Okay, here right-hand attributes may be associated with different upper layer attributes, right? But if we look at the model of this ISO, see, it's pretty clean, right? So what we want to measure is top level functionality, reliability, usability, efficiency, maintainability, portability of the system. Okay, but if we want to measure functionality, we need to, in more detail, we need to measure the suitability, accuracy, right, security, and reliability. It's maturity, fault tolerance, recoverability, right? So everything has a clear map to the lower level attributes to measure this thing. So it's a better distinguished measurement. But this one, this one actually demonstrates one of the aspects of the attributes. One of the attributes, it may have influence on different upper level attributes. For example, this integrity, robustness of the software, it influences both the reliability and human engineering aspects of the software. Alright, so that's the evaluating products. We use this model to evaluate this quality. So a baseline and the target is what the baseline target when we're doing the evaluation. So the baseline describes the usual or typical results in the organization or category. Baseline useful for managing the expectations. But the target is evaluation of baseline. It means baseline is the the typical maybe capability or the thing you want to reach, the baseline. And target is, as it means target, it's a different version. It's a variation of baseline where you want to reach the minimum acceptable behavior. So here the baseline target means this, we're still talking about this model, like how sustainability you want to reach, how accuracy you want to reach, okay, the baseline. And then analysis to the evaluating. This is the evaluating of the products here. We're using this model's attributes. These things we are interested in to evaluate the whole quality. We cannot just say the quality of this software system is 96 points out of 100. We cannot just say that. We need to describe how this 94 points, where do they come from? So all these models, they kind of help us with that kind of task, okay? And then that's the evaluation to the product itself. How about evaluating of the process? I mean the process where you conduct your development activity in the team. So evaluating the process. We have some tools that's defined to help us evaluate the process. One of them is called the post-mortem analysis. It's a post-implementation assessment of all aspects of the project, including the products, process, and resources. And it takes place shortly after project completion, or it can take place at any time from just before the delivery to usually 12 months afterward. Yeah, this kind of definition is trying to make it flexible, because sometimes they don't do 12 months this kind of measurement to this process. First, it's because of the budget, and then it's because of the time. Yeah, just a lot of the difficulty comes from the resources. If you really have the resources to conduct this evaluation to process. Okay, so the objective of post-mortem analysis is, well, on the project history day, the objective is to identify the root causes of the problem, and involves a limited number of participants who know something about the key problems, and review the schedule predictability charts. Let me show you what is it. So the schedule predictability charts here. So it's a plot of the date prediction was made and the predicted dates of the milestones. What do I mean here? Let me explain that to you. For example, so this 1/95, I mean it's an old picture, okay? 1/95, 7/95 means July of 1995. So it's an old picture, yeah. But it's a useful chart. Okay, here it's a 7/96. It's July 96. So on this point here, the x-axis is 7/95, y-axis is 7/96. That means on July 95, we made a prediction that these tasks can be finished on July 96. So here we predict that this task will be finished a year later. Okay, and on this January 96, we still predict that this task can be finished on July 96. So that gives kind of 6 months to finish this task. Alright, so that means actually what we can assume, maybe later talk about the third point before we talk about the information there, okay? And here on the actual July 96, the prediction of the finish date of this task becomes the next year, January 97, right? And again, 6 months later, the prediction becomes July 97. And then actually on the January 98, the prediction is still July 97. Well, probably here it means this task is finished, right? But what happened between them? Let's see the first 2 points. On July 97, we predict it's gonna be finished at July 96, and on January 96, we predict it's gonna finish on July 96. So what happens in between? What happened in between July 97 and January 96? This line. What can we infer from that? No, actually it's the opposite.
Are they preparing for the next project?
No, let's see. Here we make prediction it's gonna be finished a year later, and half a year later we still make a prediction that it will be finished on the same date. That means during this amount of time, this whole project is on track, right? If it's not on track, if it's delayed, the prediction will be postponed as well, right? And here, when it actually increase, make the date move forward to January 96, this kind of line, it implies that the project gets some delay, right? The project gets some delay. So here we can say, what we can say is, the whole task here on this first half of the year, first half years, the project is going well, and then the whole year the project gets some delay, and after this the project is finished, the task is finished. So that is what we can imply from this chart. It helps tell you when the project is going on well and at what time the project gets delayed, right? So every small unit is half a year. First half a year doing good, second get delayed, third get delayed, and the fourth and fifth and fourth is finished. So that's what we can imply from this chart, right? So it's a tool to help you to use the milestones as tasks to show the prediction, to help you manage, look through how you're doing in this project scheduling. It gives you information you can dig. So then we publish, after we're doing the analysis, we publish the result. So we share the result with the project team, and participants in the project history, they write a letter to everyone else, managers, peers, developers, all the stakeholders. The letter should have 4 parts: introduction to the project, summary of the findings, summary of the 3 worst factors that keep the team from meeting its goal, and suggestion for improvement activities. Yeah, well, this chart definitely gave you a lot of information on that. Okay, then we're talking about important part, the evaluating of the process. So the process maturity models, which a very famous one is called CMM, the capability maturity model. Also we have something else, ISO, the SPICE, but we're mainly focused on the CMM. Okay, have you ever heard about CMM before? Okay, so let me introduce that. So CMM is called Capability Maturity Model. It's developed by the Software Engineering Institute. Okay, all of them in there is 5 levels of maturity. Well, each level is, of course, is associated with a set of key process areas, but there are 5 levels. So why do we want that? Why do we want the CMM? So this is 5 levels, but why do we want CMM? Remember, what is CMM? It's a maturity level. So it's regarding the evaluation of the process. So who wants to know the evaluation of a company's development process? Yes, exactly. Someone who is looking to hire the company, the customers. The customers want this kind of CMM, this kind of evaluation to measure if this company is capable of doing my project. Okay. So especially think about military project. Right? Military project is a big sensitive project. You want things of high quality. You want things to be on time, right? So, because they cannot just give any any of the maybe the military project to arbitrary company who is not capable of doing this doing that kind of job, right? So because they are quality sensitive, right? So we have this CMM level of maturity, which is still popular today. Okay, so a lot of companies, they are struggling to meet the CMM level. They want to have the CMM 5 certificate, CMM 5 certificate, so that they can get the contract, big contract from a government, from military, or it's also it's also a proof, evidence that your company is able to take those kind of projects, right? So there are 5 levels of them, and for each of them, you can see how can you get up to the other level. So first level is called initial, level 2 repeatable, level 3 defined, level 4 manage, and level 5 optimizing. Okay. So here let's talk about the first one, the initial. Basically, initial is you don't have any process. You just do this job, random process. All right. All the way to level 5 is you have a process. You have a software process, and you can improve your own software process. Self-improvement of your software process. It's not only we have process, we stick to the process, It's we have process and then we keep evolving this process. Okay, so that's from level 1 to level 5. Let's talk about each of them one by one. So this is evaluating process CMM level 1. Initial it's called. So it describes a software development process that is ad hoc or even chaotic. Okay. Most of the team, maybe in a classroom, it can be level 1, I guess. So it's difficult to write down or depict the overall process. Sometimes it's just random process. No key process area at this level. Let's see. Here's the sort of this this questionnaire to evaluate. Actually, it's a questionnaire to evaluate level 2. If you answer yes to all of this, you can reach level 2. But if you answer no to any of them, it's level 1. Okay, so let's see. Let's look at some of the questionnaire and trying to think about the process of your own project team. Let's see if your team is in level 1 or not, okay, or level 2. So first, does the software quality assurance function have a management reporting channel separate from the software development project management? I believe most of the teams will fail on this first question. So its quality assurance function have a management reporting channel separate from the development project management. So that means, well, when you manage this team, quality has its own channel to report to you, right? Without maybe piss off the development person, something like that. Right. Second, is there a software configuration control function for each project that involves software development? Is a formal process used in management review of each software development? Okay, so the process, yeah, we have a process. Is it defined? If we follow this software formal process, sometimes we conduct this review, but it's a random process, right? Alright, and a lot of things like them, something like it's a formal procedure to use to produce software development procedure schedules, right? Sometimes we schedule this way, sometimes we have another method to do the schedule, right? We do this Gantt chart, critical path in this course, and in the next course we just think about we're doing the schedule according to spring break. When it's spring break, we need to schedule everything down there because we want to celebrate the spring break, right? Sometimes we do the schedule this way, sometimes we do schedule that way. So that's not a formal procedure, okay? Therefore, most of the time in the course, in the school, you are actually doing the CMM 1. So we do have a process, but it's just pretty random. Okay. So what is really something like CMM level 2? It's called repeatable. So it's identifying. So in this process, CMM level 2, you can identify the inputs and outputs of the process, also the constraints and the resources to produce this final product. All right. Yeah. Okay, so that's when you describe you are a level 2, you should at least have this figure to describe your process. So think about your project team. If we want to struggle to this level 2 process, what is it? Well, if we want to match your activity to this figure, what is the input and output of your process.
The requirements of the product.
Exactly, yeah. Input is the requirement, and the output of the process is the product. Yes. And what is control? What is resource?
Would be like a prototype?
Prototype? Well, control and resource usually they are mapping to kind of control, maybe management. And resource is more about this constraints, this the time you have, the budget you have, the things. So, given this requirements and our management, our resources, we generate the product. So that's something called repeatable, because every time when we're doing this development, we kind of have the same model, okay? But what happens inside cannot be seen here. Okay, so that's CMM2. But if you want to go to CMM3, you kind of need more specific process within this big square. Okay, constructed the system. So, but why it's called repeat? Why it is called repeatable? Because if we have this kind of model here, providing with the management resource requirements. Okay, so if we know how to make things maybe delivered early, the systems delivered early, this kind of management resource, this kind of pattern maybe repeat for the next project. Okay, it's called repeatable. But if we want to go a level up, we go to level 3. So one of the principles, remember, it's important is we can only measure in the process. We can only measure what is visible in this chart. Like the input, we can measure. The requirement, we can measure. The management, resource, they all can be measured. But within that, within this construction, construct the system, if we do not specify them into design, coding, and integration, it's hard to evaluate each individual stage of them. Okay, so here in the level 3, actually what improved is we still have requirements as input. We still have system software as the output, right? Yeah, we still have those input and output. And on the top, we still have this, it's plans, criteria, design method, such as just like the control of the second on the CMM2. On CMM3, we specify them even more. Okay, on each stage, what is the control, and at each stage, what is the resources, tools, stuffs, right? So this more specific stages replaced the big box of the CMM2. Is the CMM3. We have requirements go to the design stage, define the design, and with design we have a design method defined. We have tools, stuff, resources available to us, and then what we generate is the system design. Okay, the generation of the system design is the input of the code and the testing, and the tested modules is the output of the code testing process, and it's the input of the integration process. Okay, so that here we have a more specific, more detailed specified process in CMM3, so that we can measure each of them. Okay, so that's CMM3. Yes. And how about, well, that's a CMM3. And how about CMM4? So if you want to improve this chart, what do you think? Imagine what is CMM4. Right, CMM2 is here, big box. That's it. CMM3 is specified big box. Yeah. And how about 4? 4, let me show you. 4 is called, well, 2 is repeatable, 3 is defined, and 4 is managed. And the quantitative process management, software quality management. So 4 is called management. Imagine what is in there in 4. More boxes? Well, yeah, kind of like them. Yeah, we need more boxes to specify more stuff to the process. So actually it's this. So here it's still the same. Well, this part, right? This part. Familiar? Requirements as input, system as output. Right, but we have some kind of loops there. So what are they? What are the management there? Why do we need those management? See, what is the input of the management? So here one of them is faults to the management. The other one is problems to management. And what is that? Requirements from senior management. Right, so higher level management requirement. So we have a faults, we have a problems. I'll go to the management. Okay. So why does the management need this fault, requirement, and problems? Yes. So we can have some of our directive to the activity of design, to the activity of this kind of directives for new employees build test. So it's kind of have a loop back. Some feedback can be taken into consideration by the management. Okay, so that's CMM4. It's not in CMM3. CMM3, we just stick to this whole thing. What happened? What's wrong? It's not feedback. There's no feedback. Now CMM4, what's wrong is aware. It can be aware of the management, right? The feedback determines how resources are deployed. The basic activities themselves do not change. So we give, here we have a problem of building a test, and the management says we give more employees to the testing group because there are a lot of problems there, right? And here, we give some, allocate some new resources, just trying to do that. It seems like we're improving the process, but no. Actually, no. It's about management to distribute the resources. But within this define, design, build, test, within this process, they're not changed. The management cannot change the process within this define and the design and build and test. It's not changeable. Okay, it remains the same. So that's CMM level 4. So with that in mind, it's easily to guess what is the highest level, CMM level 5. Well, in 4, okay, we have a problems, faults. Management says, okay, you have problems, I give you more money, more people. So you solve the problem right here the same. But still we're using the same process. Okay. Alright. But CMM level 5. See that? We have the loop. We have the loop. But within that loop, the management process will change the process of this design, testing, coding, integration. Okay, so we have a different, say, T0, T1, Tn. That's a different process of this. Remember what is this input? Requirements, right? It's all the way to system, right? And we have some requirements, system, and all the way go there. We have loop to the management. But what the management can do is more than CMM level 4. CMM level 4 is we rearrange maybe resource, reallocate resources. But here we can reallocate resources. But in addition to that, we evolve the process. We change the process itself. So that's called CMM level 5, optimizing. So with quantitative feedback is incorporated in the process to produce continuous process improvement. The process itself is evolving. So that's CMM 5. A lot of companies, software companies, they are struggling to just reach this CMM level 5 so that they can get big contract from maybe government, especially government and military. And their customer will think they are more reliable if they reach CMM level 5. Okay. All right, and there are key practices of CMM. So it's a commitment to perform, ability to perform, activity to perform, measurement, verifying, implementation. So the important is remember this 4 levels and how they get improved from 1 to 5. Okay, so that's the most important thing we want to remember from today's class. Okay, and we also have some other evaluation of the process. One's called SPICE, was intended to extend the approaches like CMM. Well, you can go back and read about this. Also, I'm not going to go through every detail. And also we have ISO 9000. It's published by the ISO, International Standards Organization. Yes, to help us maintain the process, to help us evaluate the process, maintain the quality. So it's important to understand the difference between the assessment and the prediction. Prediction, what we mentioned, the prediction, measurement, and the control measurement. And product evaluation is usually based on the model of the attributes of interests. Like what I mentioned, there are 2 models, right? One of them is ISO. It's directly mapped, simply mapped. Each attribute is mapped only to one of the upper level attributes, right? So we cannot directly, the key point here is we cannot directly measure the quality. We measure each attributes associated with different types of areas of quality. Okay, all right. And also process evaluation can be done in many ways. What we focused on today is the CMM, right? So what is the what does CMM stand for? Capability, maturity, model. Capability, maturity, model. Right. Yes. Okay, and it has 5. It has 5 level. All right. So yeah, that's it for today. Thank you very much.